Hey, hello, welcome. I remain Prosper Nwangu, and in this week's lesson, we're looking at carbon and its compounds. Specifically, we're going to look at the carbonates. In our last week's lesson, we looked at oxides of carbon, such as carbon dioxide and carbon monoxide. And for carbon dioxide, we saw that the oxidation state of carbon in carbon dioxide is +4, whereas the oxidation state of carbon in carbon monoxide is +2. So for this lesson, we're looking at other compounds of carbon, and specifically, we're going to base on the carbonates. Without wasting much time, let's dive into the lesson for today. So what are our objectives for the lesson? The first objective, what you should learn at the end of the lesson, you should be able to state some inorganic compounds of carbon. Now, I'm specifically saying inorganic compounds of carbon because after the lesson, at the end of this lesson, we're going to look at the organic compounds of carbon. So we're basing on inorganic compounds of carbon. We're not going to list so much, we're just going to list a few. And the second objective, you should be able to state the properties, and lastly, you should mention some uses of this compound. I repeat, some uses of this compound. Without wasting much time, let's dive in. So we're looking at the inorganic compound of carbon. We would look at three inorganic compounds of carbon. The first one is the hydrogen trioxocarbonate 4. Now you see the sign over there, 4. Again, acid, also referred to as carbonic acid. Now we did acid base and salt. I do hope you can still remember that acid. Remember, it's a weak acid. It is an inorganic acid also. So you could pause the video and think about what you can remember about acids. Think about what you can remember about carbonic acid. From the picture we have here, from the GIF image we have here, you could tell a thing or two about carbonic acid. Let's proceed. So carbonic acid is formed by dissolved carbon dioxide in water. Now when you dissolve carbon dioxide in water, what you have is carbonic acid. CO2 reacting with water gives you carbonic acid, also known as hydrogen trioxocarbonate 5 acid. So we have here that it's a weak acid and can dissolve as shown below. So this is dissociation reaction. We've seen this in our second term scheme of work, where we discussed acids, weak acid, dissociation of acid. We're talking about strong and weak acids. So this is just dissociation. It can dissociate in two forms. Now we're going to see about this dissociation. We're going to see how it forms other compound. While we're discussing about why we see it fit to discuss about the dissociation of carbonic acid, we're going to see how it forms other compounds of carbon. So carbonated drinks are acidic due to the presence of carbonic acid. Remember when talking about carbon dioxide, we said that carbon dioxide is used in making fizzy drinks. For those that did that assignment, it's used to make fizzy drinks. Now the reason for that, now look, let's go back to this, the chemical equation we have there, where we have CO2 reacting with water to give us carbonic acid. So that's what happens when you try to dissolve carbon dioxide in water, and so it gives you that. So that's all we could take for that. When carbonic acid reacts with metallic hydroxides or oxide, it forms two types of salts, hydrogen trioxocarbonate 4 and the trioxocarbonate 4 salts. So these are the other two we're going to be looking at. The first one we just saw, or we're explaining right now, is carbonic acid. The formation of carbonic acid. Let's rephrase. Now carbonic acid is formed when you dissolve carbon dioxide in water, so you have carbonic acid. Now, carbon dioxide is referred to as an acid anhydride. Moving on to the next. Hydrogen trioxocarbonates. Now, hydrogen trioxocarbonates, let's talk about that. These are acid salts because we have one replaceable hydrogen ion still left. Now, you see, from our previous slide, we saw something like this, the dissociation of the carbonic acid. One of these is dissociated to give us hydrogen trioxocarbonate. So let us discuss what hydrogen trioxocarbonate salts are. Now we are told that these are acid salts of trioxocarbonate 4 and are made whenever a metal or ammonium radical substitutes one of the hydrogen atoms in the molecule. So It's as simple as when one hydrogen ion from the carbonic acid is substituted by a metallic or ammonium ion, just like in the formation of a salt. We have the resulting compound is a hydrogen trioxocarbonate. So hydrogen trioxocarbonate can also be prepared by passing CO2 via a solution of the corresponding hydroxide or trioxocarbonate. For instance, you could also pass CO2 into sodium hydroxide or a trioxocarbonate to give us a hydrogen trioxocarbonate. It is referred to as bicarbonate as seen in the picture. So you could refer compounds containing hydrogen trioxocarbonate as you name the metal and you conclude it with a bicarbonate. For instance, in this case we have sodium bicarbonate. So there are two ways. The first aspect is when a metal partially replaces hydrogen ions from the carbonic acid, you have a bicarbonate, and you can just directly dissolve CO2 into a corresponding hydroxide or a trioxocarbonate, and you have that. So moving on, trioxocarbonate 5, which is the last aspect. That's the third compound of carbon we're going to be looking at. So this just simply means, in this case, it is different in the sense that it's when a metal completely replaces the hydrogen ion of carbonic acid, just like we have here. Zinc is completely replacing the hydrogen ion of carbonic acid and liberating hydrogen gas. If you check it out for the first equation, second equation, and third equation, the same thing is happening. This compound are displacing hydrogen ion, and the carbonic acid, the replaceable hydrogen ion in carbonic acid is completely replaced, and that's where you get trioxocarbonate for salts. So we'll talk more about its property. Let's not base on it, but you could pause the video and read what we have here, so we'll save time. All right, one aspect that students usually miss, one aspect I want you to know is, now sometimes you have questions, almost all the time you have a question that asks you to explain or state how you could remove a sample of carbon dioxide from air. Now, carbon dioxide can be removed from air by passing it through a solution of sodium hydroxide. Of course, you get a corresponding sodium trioxocarbonate plus water. We've seen this equation in our last video, and that was why I want to dwell on so many things we are discussing here. We saw it in regards to test for carbon dioxide when we are passing it through lime water, remember? And when we talk about lime water, we're talking about calcium hydroxide. All right, so we're told that most of the metallic trioxocarbonates are insoluble in water. The common methods for preparing them are displacements of trioxocarbonates of the water-soluble sodium trioxocarbonate, reaction of a base, metal or metallic oxide with carbonic acid, and that's just that. So properties, I want to focus on this property a bit. Now look at it, you look at the table very well. You can pause the video and let us analyze this table. You may not understand the importance of what we're doing right now, but just stick with me and believe me. Now what we're doing is really important. These bits of knowledge that you tend to take for granted, like I can do this at any time, it's what's come to haunt you later on in regards to your exam. So let's look at this. Bits of knowledge. We have here potassium and sodium is soluble. Every other trioxocarbonate, every other carbonate, whether hydrogen trioxocarbonate or just carbonate salts, are insoluble in water. I repeat, potassium and sodium trioxocarbonate. Let me include one to that. Ammonium trioxocarbonate is also soluble in water. So going to action of heat. Note that potassium and sodium trioxocarbonates do not decompose when heated. Potassium and sodium trioxocarbonate do not decompose when heated, but also you should know that the hydrogen trioxocarbonate or the bicarbonate of sodium and potassium will decompose to give the carbonate, liberating water and also carbon dioxide. Now going to the next form, the next set, magnesium, aluminium, zinc, and iron. Although there is no aluminium carbonate, please, so we can exclude that. We could exclude that. So we have magnesium, aluminium, zinc, iron, trioxocarbonate, they decompose in this manner, giving us calcium oxide plus oxygen gas. So lastly, we have here going from lead, copper and silver, they decompose into the metal, oxygen and carbon dioxide. Now these decomposition reactions are really important. I repeat, you could pause the video at any point and get this right. Know this, it's important. So lastly, action of acid. Now I think this is good. It's good news. All trioxocarbonate behave in the same way in the presence of an acid. Although trioxocarbonates that are insoluble in water would form a layer, a coating, and prevent further reaction from happening. So let's see here. Say all carbonates react with acid to form a salt, water, and carbon dioxide. So I'm adding this to it. Insoluble trioxocarbonates, when they are reacting with, let's say, dilute acid, the reaction stops after a while because of the formation of a layer of insoluble compounds, depending on the acid you're using. It may just stop. All right, so moving on to the last slide. Uses of carbonates. The first use of carbonate, we have sodium. It's used for cleaning. It's used to controlling pH of water, textile treatment, and the carbonate is also used as a food additive. And I can tell you that sodium trioxocarbonate is also used in the making of glass. So it's used in the making of glass. Although you can see this in regards to potassium, but sodium trioxocarbonate is also used in the making of glass. So let's go to calcium. Calcium is used in the extraction of iron, in agriculture, in cement production, in scrubbers to neutralize acidic air pollutant. I'm not going to be explaining these uses one after the other. If you need to know what any of this terminology or the uses mean, you go online and read about it so we can save time. Now, some of these things we're going to be discussing it further when we advance. You come to know them. You come to know why it is used as a cleaning agent, controlling pH of water, textile treatment, and the rest of them. Now, moving on to the next, potassium we're told used to manufacture glass, and I want to also add to that sodium carbonate is used in to manufacture glass. Nickel is used in electroplating and manufacture of ceramics. Cobalt is used as a ceramic pigment. Whoa. So can we just summarize? Can you pause the video and think about what you've learned so far? So what did we discuss? We talked about carbonates generally. We talked about the carbonates, compounds of carbon. And we discussed carbonic acid, and we are told that fizzy drinks are acidic because of the presence of carbonic acid. And we are told that to prepare carbonic acid, all we need to do is to dissolve its acid anhydride, which is carbon dioxide in water, and we have carbonic acid. And we're told, I also told you that carbonic acid dissociates in two forms. The first form gives us hydrogen trioxocarbonate 4, and the other form gives us carbonates, just trioxocarbonate 4 on its own. Now these forms, because of its ability to dissociate in this manner, it can produce two forms of carbonate, which two salts of carbonate, one which is acidic and the other is normal. So that is all we could take for today. If you have any question, we have our Zoom class tomorrow, which is Friday. You are free to ask a question. You could approach me on my WhatsApp, and you could also ask questions in the Google Classroom. And by God's grace, I would attend to such questions. So your assignment, ensure you do your assignments. And lastly, if the name you have registered in the Google Classroom is not that which I could recognize, please, I want to urge you to go and change it so I could actually monitor your improvement and attend to you when you need it. So do have a nice day. Thank you for watching. Stay safe and observe social distancing. I love you.